Well, I'm going to bring up another buzzword in the Parkinson's research world, biomarkers, like alpha-synuclein. Why are these important for Parkinson's research? Can you share any recent trials or information about why are we talking so much about biomarkers right now?
Sure.
Maybe start with what is a biomarker?
I was going to say, let's start there. So what is a biomarker? So just as most of you in the room have gone in at some point and you've had a blood test for cholesterol, you might have had a hormonal pregnancy test. These are biological tests that tell us what's going on inside your body. There are also things like imaging biomarkers. If you go in, if you take a fall and you get an x-ray, that's kind of a biomarker as well because it allows us to look inside your body, see what's going on. That's valuable for diagnosis, obviously. It's also really valuable for other things like treatment, right? And so to support drug development and to make sure that we have treatments that are moving forward, a lot of these treatments are really going to be relying more and more on biomarkers. So to go back to the alpha-synuclein biomarker, that we had a really exciting announcement just a couple of years ago. I hope some of you have already heard about it, but briefly what I would say is that for the first time ever, there's a biomarker you can go in and they take a couple drops of cerebral spinal fluid through a spinal tap, and they can actually test that in a vial in the lab, and they can assess whether or not you have clumping of this protein that is tied to Parkinson's pathology. And if you're positive for that test, it gives us confidence in the diagnosis that you have Parkinson's disease versus something that might look like Parkinson's. But it also tells us that you are in a state where we believe you have this disease. So if you imagine that you're running a clinical trial, for example, you want to be absolutely certain that the people that you are testing a drug on actually have the disease you're trying to treat. That is the simplest way I can put it. So we think that this is a catalyst for progress in drug development. We think it's a catalyst for our ability to understand the underlying biology. And ultimately, it also ensures that people have accurate diagnoses as early as possible so they can get treatment.